Systems of equations. Chapter 5. Systems of equations. I hope that moving forward you'll find all this material much easier than the previous one. Maybe not as interesting, but at least easier. Okay, so this part, the 5.1, is really a review for you, but let's go through all sorts of methods. Let's say problem 8 on page 555, and we have 2x minus 3y equals negative 13, and y equals 2x plus 7. This is exactly a system of two linear equations in two variables. Two linear equations in two variables. Now, in how many ways two lines can face one another? Well, 3 ways. This is one solution. Here's another. No solutions. And here's the third one. This is one line. And here's the other line. Infinitely many solutions. These are the only 3 options for 2 lines in 2 variables. 2 linear equations, there are 2 lines in 2 variables. They meet in one solution. The system is called consistent. Consistent system. Because it has solutions, even if it's just one. This one is called inconsistent. Inconsistent. It has no solutions. Of course, this one is also consistent system. We will look basically at two different methods. There are many methods of solving systems, but we're going to look at 2 and review 2 of those. One of them is substitution, and the other one elimination. Also called the adding method. So 2 methods of solving systems of linear equations: substitution and elimination. I'm going to copy the system we just looked at. So let's copy it. I have to copy it because I need more room. As you see, the second equation is already solved for one variable, for y, which means that immediately I can go and replace y in the first equation by 2x plus 7. But you have to be very careful how you write it. You have to put parentheses. So this is the substitution method. I didn't really have to do anything. I realized that the second equation was already solved for y. So I am really told y or 2x plus 7 are the same. Then, knowing that, I went back to the first equation. I replaced y by 2x plus 7. And now I have an equation that I know how to solve. It only has one variable. So this is 2x minus 6x minus 21 equals negative 13. I had to distribute. I need my tens. Okay, combine like terms, negative 4x, and move 21 to the other side and get positive 8. So therefore, x equals negative 2. This is good, but it's not good enough. I have to go back now to the substitution and determine y. 2 times negative 2 is negative 4. Negative 4 plus 7 is 3. It appears that the solution of the system is, so we just encountered this situation. with one possible solution. No line can meet in 2 points. It's either one, none, or all. Okay, so it appears that the solution is what? Yes. Do I trust that? No. We go back to the original problem, and we replace x by -2 and y by 3, and perform the operations. -2, 3, -2, 3. This is -4, and -9 is -13. Yes. This is -4 plus 3 plus 7 is 3. Yes. Only now I can say yes. This is indeed true. I don't need anyone to check anything for me. I go back and check myself. Okay. Let's look at 14. Any questions on this problem? This should ring a lot of bells because I'm sure you've seen this before. But that's okay. 14. In 14, no equation is solved for us. 2x plus 5y equals 1, and -x plus 6y equals 8. We're asked to use substitution, or we want to use substitution. Okay, well, if that's the case, we have to decide which variable to solve for. I will refuse to solve for this because it has 2 in front, and I will have to use a fraction. I refuse to use this to solve for y because it has 5 in front, and I will get a fraction when I solve for y. I refuse to do the same thing with 6y. The only one that is worth our while is only with a coefficient of 1 or -1. So in this case, I have -x equals -6y plus 8, and I will multiply by -1. I get x equals 6y minus 8. This is what I go back to the first equation and replace in here 6y, x by 6y minus 8. So then 2 parentheses 6y minus 8 plus 5y equals 1. Again, by a simple manipulation, I was able to determine an equation with with only one variable that I know how to solve. So therefore, 12y minus 16 plus 5y equals 1. This is 17y, and this is 17, and luckily y is 1. However, that's not enough. I have to go back and find x. Can anyone give us x?
2.
How much?
2.
One more time. Good. So what is the potential solution? I don't know for sure yet. I haven't checked anything. So hopefully it will be -2, 1. So I have to go back to the original equation with -2, 1, with -2, 1, and check both equations. 2 times -2 is -4, and -4 plus 5 is 1. Yes, it is. -2 plus 6, -2 times -1 is +2, plus 6 times 1 is 8. Yes. So now I know that this is the correct solution, and no one can find another. This was the method of substitution. Any questions? Do we need more examples on substitution? Are we okay with substitution? Say no if you feel like doing another problem. We'll choose another. Should we? Should we choose another problem with substitution, or we move on to the second method, which is elimination? Move on? Okay, very good. Same page. Let's look at 24. So still on 555. 2x minus 7y equals 2. And 3x plus y equals -20. Yes, of course, you can solve the second equation for what variable? For y, and plug in the result in the first one. We don't want to do that. We want to use elimination this time. So here's how we think. First, I look at the coefficients of x, and I see 2 and 3. If I would like these to disappear, I will need the lowest multiple, right? Here a 6, and here -6, or vice versa, a -6 and a +6, which requires us to multiply the first equation by 3, or -3, and the second equation by 2, or -2, because I need to obtain a 6 and a -6, or vice versa. Let's analyze y. If I want to get rid of y, that's the easiest thing. I don't have to multiply both equations. I do have a -7y. What should I multiply this equation by? Exactly. So all I have to do is multiply the second equation by 7. I copy the first one as 2x minus 7y equals 2. And I multiply each and every term by 7 of the second one. So 21x plus 7y equals -140. Now, when I add these two term by term, these two go away. And that's exactly was our plan. Our plan was to eliminate y. So 21 plus 2x is 23x. And here we have -138. Therefore, x is the ratio of -138 over 23, which happens to be -6. Is this good? Yes, it's good, but it's not good enough. I have to go back to any of these two equations. Let's say I go back to the first equation, and I have 2 times -6, which is -12, minus 7y equals 2. Linear equation, so -7y equals 14, so y equals -2. Do I know that this is correct? No, I don't, not yet. I have to go back and check in the original problem. So what is this point then that I will go back and check? It appears to be -6 comma -2, but I have no clue. Maybe, maybe not. So let's go back to the original problem with -6 comma -2. -6, -2, -6, -2. Let's do this together. 2 times -6 is -12, but this is positive 14. -12 plus 14 is indeed 2. Here we have -18, and then it's a -2. -18 minus 2 is indeed -20. And this is a definite yes, and no one can find another solution. This is the one. Of course, the next level will be more difficult. What is the next level? In which we have no choice, but we have to multiply both equations by different numbers. So let's take a look. 26. And then we'll look at a word problem. 3x minus 7y equals 13, and 6x plus 5y equals 7. Okay, so first we analyze which variable we want to get rid of. So let's analyze x. I like x because if I multiply, in this case, just one of the two equations. If I multiply, what should I multiply by? 2 will not work because 6x plus 6x will not be 0. -2. Okay, let's continue analyzing. Do I want to use y? I don't, because 7 and 5 don't have a common, right? So I need to get a 35, a -35, and a +35 to get the 0 here. So I'd rather stick with x. So yes, I will multiply the first equation, both sides, by -2. So -6x plus 14y equals -26, and 6x plus 5y equals 7. And the plan worked. X is gone. So this is 19y equals negative 19. That's really nice. So then y equals negative 1. Is this good? Very good, but not enough. I have to go back to either one. So 6x minus 5 equals 7, or 6x equals 12, and x equals 2. So what do you expect? We don't know for sure yet. What do you expect the solution to be? We expect, comma, negative 1. I don't know. If I don't check, I can't guarantee. So 2, negative 1. 2, negative 1, 2, negative. So this is 6, and this is positive 7. Yes. And this is 12, and this is minus 5, 7. Yes. Only now it's guaranteed. It works in both equations. It must be it. Questions? Questions? Okay, 28, before we look at a word problem. In 28, we have 2x plus 3y equals negative 16, and we have 5x minus 10y equals 30. Here I have no choice. No matter whether I would like to eliminate x or y, I have to multiply both equations by a quantity, by a number. If you ask me whether I prefer x or y, I would say y. Here's why. Because I already have a negative. So I don't have to multiply any of the two by a negative number. Is that difficult to multiply by a negative number? No. But I may mess up and forget the sign. Who knows? So I prefer multiplying the top by and the denominator by to eliminate y. What would you multiply the top by? But negative 5 times 3, and now what will I multiply negative 10 by to get the same number? So 3 and 10 don't have a common factor. So I need to obtain a 30. Yes, and the other one by? Exactly. Exactly. So then the first equation becomes 20x plus 30y equals negative 160. And the second one becomes 15x minus 30y equals 90. That's what I wanted. I wanted to find the least common multiple. And the least common multiple of 3 and 10 is 30. There is no other smaller number that is divisible by 3 and 10 at the same time. So when I add term by term, of course, I get 35x, and I get negative 70, I think. And therefore, x must be negative 2. Is this good? Yes, very good, but not good enough. So I have to go back to any of the two equations. It doesn't matter. Negative 10 minus 10y equals 30. So negative 10y, I add 30, so y equals negative 4. We claim, but we're not certain yet, we claim what? We claim negative 2, negative 4, I have no idea. So we go back with negative 2, negative 4, and negative 2, negative 4. Negative 4 minus 12, yes. A negative 10 plus 40, yes. Only now I can say yes. This is indeed the solution. Okay, so we have 4 minutes left. We have to decide a word problem or a system with fractions. Fractions. Okay, very good. Let's say 40. 40 we have x over 6 minus y over 2 equals 1/3. X plus 2y equals negative 3. Okay, we're scared of the first one. No, we're not. Because we will simply do what to eliminate those fractions? Yes, which is? Which is? I just didn't hear. There is a fan up here and I just can't hear. What is it? But I hear when Lonnie and Michaela talk in the back. That I hear. So what is the least common denominator? Excellent. 6. So 6 over 1, 6 over 1, 6 over 1. The first term, what do I get? Perfect. The second term, minus? Very good. Awesome. And 2. Excellent. So then x plus 2y equals negative 3. Which method would you prefer? The problem does not indicate. Say it again. Yes, I would prefer that too. And I will multiply either one by? Of course. Excellent. Well done. So I multiply the top by negative 1, negative x plus 3y equals negative 2, and x plus 2y equals negative 3. That's the plan. Very well done. That would have been the easiest, right? So 5y equals negative 5, so y equals negative 1. It's good, but I still have to determine x. So then x minus 2 equals negative 3, or x equals negative 1. It appears we don't know. I can't guarantee before I check. But it appears that the solution for this is negative 1, negative 1. I don't know. I have no idea. I'll go back to the original problem. Negative 1, negative 1. This is very clear. Negative 1 minus 2 is negative 3. But the top is not that clear, so I'm going to write it here. Negative 1/6 plus 1/2. Does that equal 1/3? I don't know. So what is the least common denominator on this side? 6. So this one doesn't need anything, but this one needs a 3. So negative 1 plus 3, which is 2/6, which is 1/3. So now I'll say yes, it is true. That is the answer.